Hello everybody, Jonathan here from M Games, and in this video we're going to be setting up the player. Let's open up Github, and in the last video we set up our main menu, and then whenever we press enter, it swaps over to the game over screen, and you press enter again, it goes back to the main menu. So in this video, we're going to go to Scene, New Scene, we're going to click on 2D Scene, change this to level, and then we're going to save scene as, go to assets, scenes, levels, change this to L1. Now what we're going to do is go back to main menu, click on main menu, and then we're going to change from game over to levels on L1. And we're also going to open up the game over scene, click on game over, and in the inspector, change it from menus to levels. That way, every time we play the game, it will jump into level 1. And then if I play the game, and I press enter, it'll swap over to level 1. Okay, so what we're going to do now is we're going to go to level 1, and we're going to add a script to level. Then we're going to go to scripts, going to change this to levels, L1.gd, create. And what we're going to do is we're going to copy the script we have in main menu.gd and paste it over here into L1.gd. So a quick recap of what this script does. We have 3 export variables. The first one swaps between menus or levels. The second one holds our menus, which would be main menu, game over. And the third holds our levels, L1, L2, L3. We do not need the high score label right now. Then, under func process, we do not use delta, so I'm going to underline that. Then we have if input is action just pressed, start button. We are actually going to change this to UI cancel, because this is like a quit button. And then if the scene directory is menus or levels, we'll run the change scene function based on the scene directory, which is menus or levels. And then we have scene, which would be main menu, game over, or levels, which would be L1, L2, L3. So now that we have that set up, we'll exit out of full screen, we'll go to 2D, and what we're going to need is the player. I'm going to also set some bounds box and the background color. First off, I'll select the level, click the plus icon, and we're going to choose a color rect. Create. We're going to scale this up. I like to have it just a little bit outside of the view bounds just in case. And we can set that to kind of a dark bluish. And if you don't like seeing the background color, we can always click the eye icon. Now if we play this scene, we'll have a dark blue kind of background. Could be a little darker. That's a little better. Okay. So I'm going to hide that real quick. And now I'm going to create the side bounds. This will stop our player from leaving the view area. So we're going to create an area 2D. Then inside of that, we are going to add a collision shape 2D. Then over in the inspector, under shape, we will click the drop-down arrow and new rectangle shape 2D. Click on the rectangle shape box and change this to 32. It doesn't need to be too big, to be honest. 16 seems fine to me. Then this can be the height of your view area. I'm just going to drag this down, and with the collision shape 2D selected, we can drag this up. Doesn't need to be entirely accurate. We don't want to drag that around though. We'll just make it a solid 120. Now we'll move the area 2D down. Well, it doesn't want to, let's just change that. Select area 2D and move that down. Sorry about that. And I like to move this over just a little bit. I'm going to change this to border left. Then I'm going to Control D and border right. And move border right all the way over to the right. You can hold Shift while moving to constrain it to an axis. Okay. The next thing we're going to do is go over to Node and Groups and change this to, we're on left right now, so change that to left. And then change this to right. And now that we have the border and our background color set, we're going to create our player. So select the level, new, and then we're going to create a sprite. Then inside of the sprite, we're going to add an area 2D and a collision shape 2D. This is going to appear in the top left. Now over in our file system, we can go over to Assets, and then we're going to right click and New Folder. Change this to Sprites. Then we're going to right click on Sprites, New Folder. Change this to Players. And then select Players, right click, New Folder, Player 1. And then I have an image. Okay, now that we have our player added to the scene, we are going to select Sprite and go back to the inspector, change the texture to the sprite that you want to use, Assets, Sprites, Players, Player 1, and player1.png. You'll notice that it looks a little blurry, so what we're going to do is select the player1.png, go to the Import tab, select Preset, 2D Pixel. And I like to set this as default for texture, and re-import. Now it looks much better. So let's go back to Scene, select Collision Shape 2D, drop down arrow, New Rectangle Shape 2D. Now we can select our arrow and scale that down. Select the area 2D. We can move that down a bit. Go back to the collision shape and adjust the size of it. Now we have the area 2D node scaled properly. I'm going to double click on Sprite and change that to Player. And the other thing that I'm going to do is right click, and I'm going to save branch as scene. Go to Assets. We're going to right click, New Folder, Instances, and right click, New Folder, Players. And we will change this to player1.scene, save. And now we can move this around. going to move this somewhere around the middle, down towards the bottom of the screen. And if we play the scene, our player is now somewhat centered. You can even check it with the background color if you wish. Now let's try to make the player move. So we're going to right-click on the player, or you can left-click player, and then in the Scene tab, you can attach a new existing script. I like to have no comments, and select the folder icon, go up to Scripts. We're going to right-click, New Folder, Players, and player1.gd, create. Now, what we're going to use is a state machine to tell if the player is moving or standing still. So in order to do that, you're going to type enum and I'm just going to enter and move that down. And then I like to have them all in capitals. So hover is what's going to be our standing still. Add a comma. And we're going to have move left, move right, and for the fun of it, mouse move. Now that we have our states, we need to assign it to a variable. So onReady var state equals hover. So now that we have our state, let's create a new function. I'm going to do func physics process. And what we're going to do here is we're going to check our state as well as set our inputs. So first thing to set up will be match state. So this is basically just checking what state we're in. And then from here, we can enter in hover or move left as an example. We don't need hover as that's not really running any code, so we're going to be fine there. We will be using move left and move right though. So now, let's check our inputs. So this will be setting our state. If input.isActionPressed, so if we're holding down UI left, then we're going to set the state to move left. And the opposite of that, I'm going to type in L, then paste the first line we just made, elif UI right, move right. So now, since we're matching the state, it's always checking if state equals move left or move right, and whenever we are pressing or holding down UI left or UI right, we're setting that state. So, just as a quick test, we're going to get the global position of our sprite, our player sprite, .x minus equals, I'm going to set this to 50. And the opposite of that, for the right, we're going to do plus 50. So if we play the game now, we are moving a little too quickly. Also, the player is going to continue to move whether or not we're holding down or not. So I'm just tapping the key and the player continues to move. So what we're going to do is elif input is action released So if we just released UI left or, let me go full screen for this, UI right. So if you're removing UI left or UI right, state will equal hover. So now if I run the game, the player will move and stop. But it goes off screen. So what we're going to need to do is check our bounds. In order to do that, we are going to go into the ready, and then we're going to replace the pass with get node area2d connect area entered, comma, self, comma, and then the function name, which will be collided. We'll also use this with enemy bullet hit or other things too. I'm also going to duplicate this. And then this is going to be exited. Colliding. There, that looks a little better. So we will create a new function, colliding, with area, and we'll just duplicate this. And then this is going to be not colliding. Technically we don't need area here, but we'll keep it. Okay, so we need to figure out how to collide with the border left and border right. So earlier we set up the node with group of left or right. So we need to access that. Go over to scripts, and then we're going to if area, so we're getting the colliding area dot is in group left print left. So we're going to check if area is in group left. So if we play this, and then we go all the way to the left, every time we collide with the left, it prints out in the output. Oops. Let's go to scripts, and now that we have that code, what we're going to do is, I like to create a variable, var, this one is going to be while colliding equals none. All caps. And then we'll set that here to while colliding equals left. And we'll do elif right while colliding equals right. Now, since we created the not colliding, we're going to set that here, except we don't need to do that. Oops. Just set while colliding equals none. And we'll go over here, move left. If while colliding doesn't equal none, oops. Then we will tab that. So now if I play the game, the player will not move. because it equals none. So what we need to do is doesn't equal left and right. Play test the game again, and we can move left and right, and if we collide with the wall, the player will not pass through it. So if we move the border left or the border right over and play test the game, you can constrict the player to a certain bounds area. I'm just going to undo that. And now that we have that set up, we can change the speed of this to a constant variable. So const speed equals 50. Now we're going to change plus equals speed times delta. So now our speed is easier to access. So if we play test the game, the player should move a little bit more efficiently. Now for the fun of it, let's make the player move to the mouse cursor. So in order to do that, we are going to add a variable. I'm not going to add it here because we might want to change it from somewhere else. So I'm going to go to globals. I'm going to enter var and then player control equals keys. I'm going to make a little comment here. I'm just going to save that. Now we'll go back to our player script. And for all this, so what I'm going to do here is wrap this in that variable. So we'll do if global dot player globals.player control equals keys. And then we will wrap that in there. So now, as long as that player control equals keys, we can move with the keyboard. But if I go back to globals and change it to mouse, save, play the game, the player will not move. So let's go back to scripts. We'll leave it on mouse for now. So, going to select that, paste it, change that to an elif, change this to mouse. Now what we're going to need to do is get our mouse position and our player position. Luckily both of those are fairly easy to access. So what we're going to need to do is create this little if check. So if we're going to round the global position of our player .x equals round get global mouse position .x. And then we'll set our state equals hover. So what this is doing is we're checking if the global position of our player is equal to the global mouse position And then we're just setting the state so that our player doesn't keep moving left or right. Now, we're going to do else. If round global position.x is less than round get global mouse position.x. State equals move right. So, wait. Yeah, if the player position is less than the mouse position, then you want to move the player to the right. And what we can do here is an else state equals move left. And if we play the game now, the player will not move. Okay, so if globals.player control equals mouse, and that might be my bad for setting this here. Yeah, that probably shouldn't be here. So we're going to cut that. That way the state is always able to check. And we're going to select this line, hold Shift, and press Tab. We'll move all the selected text to the left. Now if we try to run this, it moves over to the mouse cursor. And it stops whenever it reaches that position. And if I go all the way over to the left, the player does not pass through the wall. Same should be over here as well. Yep. And of course, if we change the globals to keys, run the game again, the player will not move to the mouse, but the keyboard will control the player like before. So now what we could do is, I'm noticing some debug errors. Like chain scene 2. There's technically no error here, but it likes to warn me that there's something. So what you can do is click on this yellow warning symbol, and then click on ignore, and it will add this warning ignore return value discarded comment, and that shouldn't appear anymore. And same thing with the area connect. I'm going to click on ignore and ignore. And now I'm going to play the game. I'm going to press the start button, and I can move the mouse cursor, and it won't follow the mouse, but I can press the keys and the player will move to the keyboard. If I press escape, it will go to the game over menu, and if I press the enter key again, it will go back to level 1. We have 4 more debug errors. Just going to ignore. Actually, undo that. We're not using process delta, so just add an underscore here. This scene can be ignored. That delta is fine. Run the game again. Enter. Move around. Escape. Enter. No more errors. No more debug warnings. And now we can save. And that's it for this tutorial. Thank you for watching, and keep an eye out for more in the future.